moving forward, now that we have these properties of exponents, let's finish off chapter 5 in the next couple sections by talking about polynomial operations. And I don't think we've really mentioned the term polynomial yet. So it seems like a fair place to start. And polynomial if we just break it down, because we all know our Greek prefixes, right? Poly, right? You might be familiar with that. Poly means many, right? And nomial, right? You might take a stab and guess that means number. So this could literally mean many numbers. Right? In our case, instead of classifying it as numbers, I'm going to classify it as terms. Right, so a polynomial just means I'm looking at an expression with many terms in it. Right, there's alternate forms of this word. Right, like if I wanted to talk about a monomial, right, mono, right, being the Greek prefix for one, so monomial would be one term. We can have, let's look at some examples, like one-term expressions. Right, it would just be the number 3, just a single number is a monomial, right? Or we could have 6x squared. This is a single term. We talked about terms being a coefficient, right? And one or more variables to a power. Right? So our negative 3 a to the 4th b squared. These are all examples of terms, one single term. Right? We have binomials. Right, this would be our first type of polynomial. Now it's going to have multiple terms and with the Greek prefix bi meaning 2. Right, I'm going to stop here with a couple examples, but right, this could keep going on with trinomials and quadrinomials. I'm sure there's a name for all of them, but eventually once you get past binomial or trinomial, usually just characterize them all as polynomials, meaning they have more than one term, many terms. So some examples of polynomials. X plus 1. Right? It's a variable and a constant term. They can't be grouped together. So there are 2 terms in this expression. 4a squared minus 2b. Right? Again, 2 terms that can't be grouped together. I think we get the point. And if it's got 2 terms, it's a binomial. 3 terms, a trinomial, and so forth. So right, here's our idea behind polynomials. So we're going to be looking at polynomials, binomials, trinomials, and try to operate on them. So in 5.3 specifically, we're going to look at 2 operations, addition and subtraction. Right? In the rest of chapter 5, we'll look at multiplication and division. Right? So a couple other quick definitions. Right? When we're looking at a polynomial, we like to talk about the degree. Of a polynomial. The highest power. Highest power in any term. Right, so for example, if I was looking at this binomial here, the first term has a power of 2, the second term has a power of 1, so the degree of this polynomial would be 2. Right, this actually tells us a lot about a polynomial, right, that if you take college algebra, we'll explore some more. Right, but for now, we just want to be able to identify the degree. It's nice and common convention when you're writing a polynomial to write it in decreasing degree. We write the highest power first, then the next highest power, next highest power, next highest power, all the way down to the lowest power. So degree can help us kind of categorize and write down in a nice way each polynomial. So we have degrees and polynomials. Right, now we can focus on what actual operations are we going to be doing. Right, problem like this. Right, the parentheses are in there solely to let you know and keep your mind focused on the fact that we're dealing with polynomials. So they're saying in this set of parentheses, here is one polynomial written in decreasing degree. Degree 2, degree 1. So the degree of this polynomial is 2, but we're decreasing the powers by 1 as we go. So this is the standard way to write this polynomial. Right, this would be a trinomial, 3 terms. And here's another polynomial, 3 terms with degree 2. And they're just separating them by putting them in parentheses. Are they necessary in this problem? No, not really. Because we've already talked about how to do this. How do I add, right, expressions together? Well, you look for like terms. Right, and just as a refresher, right, when you're looking for like terms, you need same variable and same exponents. Alright, so like terms here would be 4x squared and 2x squared. You can group those together. We're just adding, so 4x squared plus 2x squared would get us 6x squared. We can group the x terms together, a positive 3x plus a negative 7x. Positive and negative should group together to get negative 4x. And then negative 7 plus negative 1, that would be both negative. We can add them up and get a negative 8. And that would be our final answer. Actually, we're just grouping together our like terms. Right? Remember, right, don't get this confused with the last section or the last sections that we talked about. Right? When we're adding terms together or subtracting or just grouping in general, we look for like terms, and when we group them together, the exponent does not change. Never, ever, ever change exponents when grouping. Right? So that would mean adding or subtracting. That does not happen. We're just counting how many of each type of term I have. If I have 4x squareds and 2x squareds, when I group those together, how many x squareds do I have? I have 6. Right? It doesn't change the type of term I have. I still have x squared terms, so be careful with that. We only change exponents when we're multiplying or dividing or raising to an exponent. Those 3 properties of exponents we had. All right, so a couple more examples of this. There's nothing special or fancy here that I can trick you with. We're just grouping together like terms. So again, polynomial plus another polynomial. Some people do like to do these problems vertically. It might make a little more sense to match up. Like if I'm saying I have like terms, why not put them right next to each other? So I'm not opposed to this, and it might help visually work this out better. Just putting these north and south and matching up your like terms. X squared terms, well, I have 3x squared and negative 2x squared. All right, x terms, I have positive 6x. Negative 5x. Okay, and then constant terms, I have negative 4 and positive 4, and I want to add these two together. So I'm grouping these up. And 3x minus 2x. 3x squared minus 2x squared would be 1x squared. I guess you don't need the 1 there. Okay, 6x and negative 5x grouped together would be a positive 1x. Again, you don't need the 1 there. Right? And then negative 4 and positive 4, those cancel out completely. There's nothing. So in fact, when we group these two together, you just have 1x squared plus 1x. Right? So if the vertical helps you, that's fine, but lots of people will just look at this and say 3x squared plus negative 2x squared and come up with their answer. You don't need to write it this way, but it's nice, a nice visual. All right, let's see what would happen in this case. All right, if instead of adding, we wanted to subtract. All right, subtraction you have to be extra careful with, and I cannot emphasize this enough. And as we go forward in chapter 6 and chapter 7, I'm going to say it over and over and over again that when you're subtracting a polynomial, multiple terms, you have to be very careful and let yourself know and remind yourself that you're not just subtracting this first term, you're subtracting every term that follows. All right, so if it helps, and I strongly suggest doing this, to eliminate this set of parentheses by saying, this is actually a problem that I need to take care of first. This is like a -1, right, out here that needs to be distributed. I mean, it's always going to do the same thing. That looks like it's going to the power, but it's not going to this term. Right, this negative is going to be distributed to all the terms that follow, and it's going to do the same thing every time. It's going to change the sign. Negative times negative will be positive. Negative times negative will be positive. Negative times positive will be negative. It's not actually going to change the numbers that you have, just the signs of them. Right? This polynomial doesn't change at all. It's not being affected by this -1. So we can rewrite it as 3x squared plus 6x minus 4, negative negative, would be positive 2x squared. So I suggest doing this step first, negative negative, and then negative positive. Right? If you don't do that step, it's very likely that you're going to make a mistake. Right? But I mean, you get accustomed to this, you can technically do it. Right? Lots of people will say this is 3x squared minus -2. They'll be like, oh, minus negative, that's plus. So 3x squared plus 2x squared. And we'll get the same thing as down here. We'll get 5x squared. All right, go to the next term. This is 6x minus -5x. So, oh, they'll say minus a negative. That's a plus. So 6x plus 5x. And that's what we have down here. 6x plus 5x would be a total of 11x. Right, and then also in the end we have -4 minus 4. Right, and you might think, okay, that's -8. And again, we have that down here. -4 and -4 should group together to get -8. So no matter how you want to do it, I strongly suggest while you're just learning it and practicing it to put this -1 here, distribute and rewrite. Right, but the more comfortable you get, yeah, the quicker you can go. So let's do one more subtraction problem over here, and that'll kind of round out section 5.3. Again, since I'm subtracting, I'm going to be very careful with this negative and distribute it to all the terms over here and make sure I'm changing their signs. 2x to the third minus 5x plus 1. Negative and positive. Negative and positive. Negative. Negative and negative would be positive. So I've changed all the signs in that second polynomial that's being subtracted. Group together our like terms. This one I've tried to put a little bit of a trick in just to keep you honest. Right? But I do have x cubed terms, 2x cubed, negative 7x cubed, that'd be negative 5x cubed. Right? When I look down this list, right, I see a term that just has an x in it and a term that has an x squared in it. Right? These cannot be grouped together. Right? And they don't have any counterpart that is a like term. So if I'm going to write this in standard form, I'm going to pick the next highest power. I can't do anything with that. It's just negative 4x squared. Right, same goes for negative 5x. There's no other term in this sequence that it can be grouped up with, so I'll just have a negative 5x. Right, but my two constant terms, these can be grouped together, a positive 1 and a positive 6 should be a positive 7. So we can certainly group those like that. So just because you have polynomials that are being added or subtracted doesn't mean all of the terms can be grouped together. Right? There can be situations that we just have extra terms that are standalone. They can't be simplified or grouped. Right? So that's our task, simplify everything that we can.